Hello students, welcome you all for Standard 8th General Science Digital class. Today we will begin with Chapter 3 Force and Pressure. Let's understand what is a force. We use force several times in our day-to-day life. For example, opening a door, riding a cycle, lifting a bag, etc. So, let us define force. A force is a push or pull upon an object resulting from the object's interaction with another object. Let's see the types of forces. Contact force. What do you see in the images? A boy kicking a ball away, men pushing a truck, man lifting weight. These are examples of muscular force. Here, muscles in our body expand or contract. A force is seen to work through a direct contact of the objects or via one more object. Is there any other contact force? Yes, force of friction. Let us understand. When a ball is kept on a table and pushed a little, it moves ahead and gets slow and stops. Also, a car running on a plain road travels some distance and stops after the engine is switched off. So, why does this happen? This is because of the force of friction between the ground surface and the object in motion. In the absence of frictional force, the object would have remained in motion. Also, frictional force is very useful in our daily life. For example, while walking, we push the ground behind with our feet. In the absence of frictional force, we will slip and will not be able to walk. So let's define contact force. A contact force is any force that requires contact to occur. We have learned contact forces where contact between the objects is necessary for the force to operate between them. But is it always necessary that the objects need to be in contact for the force to operate between them? No. See the images. When we rub a plastic comb on our hair and bring it closer to small pieces of paper, it sticks to the comb, even though the paper pieces were not in contact with the comb. Here, the comb has an electrostatic charge and there is an induced opposite charge on the pieces of paper. The force exerted by the comb on the pieces of paper is called electrostatic force and is a non-contact force. When a magnet is kept sufficiently close to iron nail, it gets attracted to the magnet even though the nail and the magnet are not in direct contact with each other. Here, the force acting between magnet and iron nail is magnetic force. As a contact is not required, hence magnetic force is a non-contact force. When an apple falls from the tree, why does it fall towards the ground? Earth exerts a force on the apple. Earth always pulls the object towards it. This force that the earth exerts on an object is called gravitational force. Here, a contact between the object and the earth is not necessary and hence gravitational force is a non-contact force. So let's define non-contact force. A non-contact force is any force that acts between two bodies that do not require physical contact between the bodies. Examples: electrostatic force, gravitational force, magnetic force. Balanced force and unbalanced force. See the pictures. What do you observe? When equal masses are kept on either side, equal gravitational force acts on the masses. This means balanced forces act on the box with effective force equal to 0, as these are acting in opposite directions. On the contrary, if more mass is kept on one side, the box starts moving in the direction of the box with more mass. That is, when unequal forces are applied to the box on the two sides, an unbalanced force acts on the box, resulting in imparting motion to the box. Children playing tug of war pulls the rope in their respective sides. If the pull of the force is equal on the two sides, the rope does not move. If the force is more on one side, the rope moves in that direction. It means there exists an unbalanced force which made the rope move in that direction. Let's see few important points about forces. If several forces are applied on an object in the same direction, a force equal to their addition acts on that object. If two forces are applied in one object in directions opposite to each other, a force equal to their difference acts on the object. A force is expressed in magnitude and direction both, and hence force is a vector quantity. Newton's first law of motion. A stationary object on which no force is acting remains stationary. An object in motion continues to move with the same speed and direction when no force is acting on the object. This is called Newton's first law of motion. This law is also called as law of inertia. So let's define inertia. Inertia. The tendency of an object to remain in its existing state is called inertia. Types of inertia. First, inertia of the state of rest. Second, inertia of motion. Third, inertia of direction. Let's see types of inertia one by one with examples. Inertia of the state of rest. When a cardboard is kept on a glass with a coin on top of it, you can actually put the coin inside the glass without touching it. Yes, you can. We have to suddenly pull the cardboard and the coin falls into the glass, as the coin tends to remain in the state of rest. So, let's define inertia of the state of rest. An object in the state of rest cannot change its state of rest due to its inherent property. This property is called inertia of the state of rest. Inertia of motion. Have you ever seen this? When a person gets down from a moving train, he falls falls in forward direction. This happens due to inertia of motion. When a person gets down from a moving train, their upper body is still in motion, and when it comes in contact with the ground which is at rest, their body topples forward due to the inertia of motion. So let's define inertia of motion. The inherent property of an object due to which its state of motion cannot change is called its inertia of motion. Inertia of direction. Did you ever experience this? While traveling by a bus or a car, when it takes a sudden turn, we are thrown opposite to the direction of turning. This happens because of inertia of direction. So let us define inertia of direction. The inherent property of an object due to which the object cannot change the direction of its motion is called directional inertia. Students, today we have learned force, contact force and non-contact force, balanced force and unbalanced force, inertia and types of inertia. Students, you will write the definition of contact force, non-contact force, inertia and types of inertia. Also, Newton's first law of motion in your notebook with examples. Hope you have understood the concept. Thank you.